As I told you earlier, a physical model is the implementation of a logical model for a specific database technology. So in this lecture, we're going to take our logical data model and create a physical data model for MySQL. So here in MySQL Workbench, on the top, let's go to the File menu and select New Model. Now, this EER that you see here is short for Enhanced Entity Relationship. So here we can also create entity relationship diagrams. Now, by default, this model assumes a database called MyDB. We can right-click this and go to Edit Schema to rename it. So let's change the name of this database to School. Now, we haven't created the database yet. This is just a model or a physical model for that database, okay? Now, on the top, let's add a new diagram. In this diagram, we can add tables and views. So here's the icon for adding a new table. Let's click this and add it here. Now let's double click this and rename it to something meaningful. In this case, students. Now, when it comes to naming tables, I personally prefer to use plural names because a table is a container for several entities like students. Some people prefer to use singular names for their tables, and they have their own valid reasons. Whatever you prefer, go for it, but stick with that convention. If there is already a convention in place, follow that. Don't break the rules. It's much better to stick to the existing convention, even if it's not ideal. Otherwise, your development and maintenance cost is going to increase pretty quickly. You have to constantly remember if a table name is singular or plural. So in my logical models, I use singular names for my entities, and in my physical models, I use plural names for my tables. All right. Now let's add columns to this table. First, let me zoom in a little bit so you can see clearly. That is better. Now I'm going to close the navigator panel. So here's our table designer. Here we can add the columns in this table. Now back to our logical model. Here are the columns that we need to add: first name, last name, email, and date registered. So first I'm going to add the first name, first underline name. So here I'm following a different convention. That is a MySQL convention. We separate multiple words using an underscore. Now the type of this column is going to be varchar of, let's say, 50. So as I told you before, I use standard lengths for my strings. So for shorter strings like username, password, first name, I use 50. And for medium length strings, I use 255. This is just my personal preference. Now you can see by default, MySQL marks this column as a primary key. We don't want this to happen. We're going to talk about primary keys later. So for now, let's uncheck this box. Now here, this column is marked as not null, so we cannot accept null values in this column. That's good. Now let's add the second column. Last name, also varchar of 50. We want to mark this column as not null as well. Now let's add the email, also varchar of, maybe 50 is not enough here because perhaps some people's email is longer. So I'm going to go with 255. And also we want to mark this as not null. And finally, we're going to add date underline registered. And for this, we're going to use a date time so we can store both the date and the time this student registered. Also, we want to mark this as not null. So at this level, in this physical model, we have the exact types in MySQL. We also know if columns are nullable or not. We can also set the default values. This is the difference between a physical model and a logical model that is independent of database technologies, okay? So here's the end result. This is our students table. Now it's your turn. Add the other entities that we defined in our logical model to this physical model. For now, don't worry about their relationships, just add the tables and their columns. You'll see my solution next. All right, here's my solution. So we have two new tables, courses and enrollments. In the courses table, we have title of type varchar of 255. For the price, I have used decimal of 5 and 2, and that means we can have a maximum of 5 digits with 2 digits after the decimal point. So the maximum price that we can allow here is $999. Now, how did I come up with this? Let's say I talked to the business stakeholders. So they told me that the maximum price they want to allow on their website is $999. Now, if this rule changes in the future, we can always come back and fix this. So I didn't go for a decimal of 9 and 2 right from the get-go because that would waste our disk space. As I told you before, keep things small. Next, we have instructor. For the instructor, I have used varchar of 255. We could go less, like 50 characters, but I just wanted to be on the safe side, so that's why I used 255 characters here. And also for tags, I have used varchar of 255 characters. Now, all these columns are required, so we do not accept null values. Here we have the enrollments table with two columns, date and price. Note that I have called this column date, not enrollment date, because this is a little bit repetitive and redundant. I've seen a lot of data modelers prefixing their column names with a table name like enrollment date and enrollment price. This is really unnecessary and makes your code ugly. Date is an attribute of enrollment, not enrollment date, okay? So just a little side note, now the type of this column is date time, so we can store both the date and the time someone enrolled in a course. And the price column in this table is also a decimal of 5 and 2. So look at the consistency between these tables. All right, we're not done yet. Next, we need to add a primary key to each table and define the relationships between these tables.